All right, welcome back. So let's have a almost our next round of test prep. This is going to be number 7. So let's go ahead and have a look at that. So we have 7 here. What 7 says is that I want to give you a position and time graph, okay? And then you have to figure out what the velocity graph is going to look like. So I'm going to put this on grid paper, not the example, but the test will have something on grid paper for you. And then you'll see something like, okay, we have time, right? And then we have position. Okay, you'll have a graph that looks something like this. And then maybe go straight across for a while, so it's not changing position. Time is just ticking. And then we go change position up a little bit. These are different slopes. And then we'll immediately reverse course. Okay. And then stay here for a little bit, and then we will go off the chart that way. So what I'm going to do is I'm going to see if I can't draw the same x-axis on here, and what's going to happen. So in order to draw this graph, okay, what you're going to have to do is you're going to have to figure out what is this slope here. Okay, so we're going to have our M1. Okay, clearly it's negative. Again, there will be grid paper for you to do calculations on to change your change in y and change in x, okay, in order to be able to do that. So it's a constant slope. Okay, so we're going to get something down here. Okay, I'm trying to line up the x's on here. Okay, I did a terrible job. After that, we don't change the position. So that graph, that slope is going to be 0 here. So we're just going to move to a 0 here. Okay, and then at this point here, I think this time 1, time 2. Okay, at time 2, it takes off again and has a positive velocity. Okay, and again, there'll be grid paper. You'll be able to figure out delta y, delta x here. Okay, and figure out what this little piece here is going to be. What is the slope of this triangle here? Okay, and then again, we immediately come down, change to a negative slope. So again, there's going to be a little triangle. You'll be able to figure out the slope for this, but it's negative. So we're going to be down here somewhere. It may be a different slope than the one that was first. Okay, different. And we're back up to here at 0. And then we have the final speed off at the end here. We're going to have a positive slope. We can do a rise over run that way. Okay, and we might get something like that. Okay, so that's the kind of graph that you're supposed to come up with for these types of functions. Okay, so this says draw the position graph, and then you're going to use the slopes in order to generate what the velocity graphs are going to be. And that's all there is to that one. Okay, and again, there'll be grid paper. You'll be able to calculate slopes, delta y's, delta x's off of all of these. There is no delta y on this one, so it's just 0. Well, delta y is 0, I should say. There is one, it's just 0. But you should be able to figure out the slopes of these triangles the entire way through. And again, because of the grid paper, you'll be able to count. Just do rise over run. That's how those go. Okay, so we'll go off to number 8 here. Okay. And we turn the page. My number 8 says something clever like we have the equation of motion is S of t is equal to t cubed minus 12t for t greater than 0 seconds. It is measured in meters, t is measured in seconds. Okay. What is the velocity? What is the acceleration? What is the acceleration when the velocity is 0? So let's write down the problem. So S is equal to t cubed minus 12t. So we have S of t is equal to t cubed minus 12t. Well, the first thing they said was, hey, what's the velocity here, right? It's the velocity. So we just take the derivative. Okay. So S of t, S prime of t is equal to 3t squared minus 12. Right. Let's see, what is the acceleration? So we need s double prime of t. That's just going to be 6t. 12 is a constant, so under derivative, that is 0. It says, what's the acceleration when the velocity is 0? Let's go back to the velocity and say, set our velocity, 3t squared minus 12t, equal, or minus 12 rather, not 12t, just minus 12. Okay, 12. There we go. I never wrote it. Minus 12t equals 0. Factor 3 out for both of these. So we have t squared minus 4 equals 0. You could solve this a number of ways. We might say t squared is equal to 4 plus t is equal to plus or minus 2. What did they say about t? They said t was positive. So we're going to pick that one. So t is equal to 2. So what was the velocity, or what was the acceleration when the velocity was equal to 0? Well, when t equals 2, the velocity equals 0. That was the whole point of this. So we'll go back here and we'll say 6 times 2 is equal to 12. The velocity is, or the acceleration rather, is 12 when the velocity is 0. And that happens when t is equal to 2. All right, so that's how you do the problem like that. Looks a lot harder than it is. Okay, and this is problem number 9, I believe. And what do we have for problem number 9? We have construct the equation of a tangent line, construct the tangent line to the graph x squared minus 1 over x squared plus x plus 1 at the point 0, negative 1. Write your answer in y equals mx plus b format. So the first thing we got to do is, well, we need a tangent line. So the idea here is we're going to use y minus y naught equals mx minus x naught. Well, m is a slope. And you might ask, well, gee, I don't know, how can we get a slope of an arbitrary curve somewhere? We might have something to do with the derivatives, so let's try that. Okay. So what is our function here? F of x was, we have x squared minus 1 all over x squared plus x plus 1. Okay, and you have to remember it's at the point 0, negative 1. Okay, so we're going to use that at the end to plug a point in. But we have to figure out, okay, what is f prime of x? Okay, it's a quotient rule, right? So we have derivative at the top. So we have the derivative, we have 2x, we have x squared minus 1. Take this derivative times the second, x squared plus x plus 1 minus the first, x squared minus 1 times the derivative, x squared plus x plus 1. Take the derivative all over the bottom squared. So we have this x squared plus x plus 1 all squared. Okay, hopefully that won't come into anything, because that looks terrible. So all I did was just kind of lay out the plan of what I wanted to do here. You don't have to do it this way. It's just the way I do it. I know a lot of you have learned taking quotient rules and product rules and chain rules in other classes from other people, and you're doing just fine. Stick with that. If it's working for you, stick with that. So I like to set them all up first, and then we'll go ahead and take our derivatives. So we have 2x. Okay, the minus 1 doesn't go anywhere, and we just have x squared plus x plus 1. Okay, back in my home, when we had Christmas, we had I have 2 siblings, so 3 of us had to put together the Christmas tree. It was a lot of fun. But my parents had a lot of Christmas ornaments that had some assembly required. Okay, so what they would do is they would get the Christmas ornaments, and then we'd have little trays. And I was the oldest, so I got to go. My year was first year. I was like, okay, you get the hard ones this year. So I did those, and then what you do is you just set the things into the trays, and like you just put them kind of together in the tray. It's like this one needs to be assembled more this way. This goes together, so we put them in the tray next to each other. Put the next one in the tray. This thing needs to be assembled. So I just kind of lay them out that way. You know, and the next year my brother got to go, and then the year after that my sister got to go, and then we rotated, and you know, then I got to go again. And every 3 years it was your turn to put together the some assembly required Christmas ornaments. That some assembly required by design. That wasn't like we broke them and now they're some assembly required. So we have to do the derivative here. Sorry about the long story there. So we have 2x plus 1. Okay, this 1 doesn't have a derivative, has a 0 derivative. And now at the bottom here, we just have x squared plus x plus 1 all squared. Well, this is the kind of derivative that says, why do we ever have to simplify? Now we have to simplify. So this is equal to, we have 2x cubed, right? That's a 2x times x squared plus 2x squared. Okay, and then we have, at the end, we have plus 2x. We have a minus, and then we're going to have x squared times 2x. We're going to have 2x cubed. Okay, we have a x squared. Okay, we have a minus 2x here. And then we have a minus 1. And then again, this is all over the bottom stuff. Okay, I'm going to double check to make sure I got that right. So of course I did this before I showed you guys. So we end up with x squared plus x plus 1 all squared. All right, so let's go ahead and distribute that negative sign. So we're going to have 2x cubed, okay, plus 2x squared plus 2x. And then we have to say minus 2x cubed. We have a minus x squared. Okay, minus and negative is plus. We have a plus 2x here. Okay, that's this minus and this plus 2x. And we have a plus 1, and this is all over your bottom squared. I'll just write that for the sake of being nice about it, but if you called it something else, that's fine. Plus 1 squared. And simplify this. The x squared, the 2x cubes, those disappear, so those are going. Let's go ahead and be clever about it. Say these guys will cancel. We have a 2x squared minus a 1x squared, so we're going to end up with x squared. 2x plus 2x is equal to 4x, so we have plus 4x. And then the only thing we have left is a 1. And this is over x squared plus x plus 1 all squared. Where is this? This is at the point 0, negative 1. So the y is negative 1, the x is 0. But what happens at x equals 0? What is the value of our slope at x equals 0? When x equals 0, our slope, we'll just use m for the sake that that's a slope, and we have 0 plus 4 times 0 plus 1 over 0 squared plus 0 plus 1 all squared. I think at that point you could see, well, we have 1 over 1. Okay, so that's a fancy slope there. So we're going to go back and say y minus, what's a y value? Negative 1. Okay, because this is the point. Equals our slope, m, x minus, what's the x value? 0. So we have y plus 1 equals, our slope is 1, so we have x minus 0, and then we'll have y equals x minus 1. So all of that, so it's a nice calculus question when you do all this work and you end up with like y equals x minus 1. Yeah, that's it. Okay, so that's how you do a problem like that. So yeah, there's a rough. Please expect one kind of like this. Okay, I think this is a good problem for us. So we'll leave you with that. I think that was number 9. Do I have a next one here? I do not. That was the end. So thank you very much for watching the video. Best of luck with the test. I'm sure everybody's going to do well.